Alright, so good day. Now for today's demonstration video, we'll be looking at SQL Join. Alright, and this will be done using Microsoft SQL Server. Alright, specifically the IDE that I'll be using to basically run the SQL commands is the SQL Server Management Studio. Alright. So what I would advise is that if you don't have SQL Server installed as yet, you can just go to the link that is now being displayed on screen. It will take you to the Microsoft website where you can download SQL Server. Two options will basically be presented to you, the developer or the express. I would say go with the developer, especially if you are a student. All right, that's good enough. And then after installing Microsoft SQL Server, you'll get an option to also install the SQL Server Management Studio. All right. Now, specifically for today's task, which is us creating or writing some SQL join statements, let me just start off by just giving you a quick definition of what an SQL join statement is. All right. So by definition, an SQL join statement is used to combine data or rows from two or more tables based on a common field between them. All right. So typically we would run query on a single table, but in the real world, many times you'll have to run your SQL commands on multiple tables. Again, you'd have to be careful with that because you don't want to overcomplicate your join statements. But regardless, the join statements are there and we can use them as we see fit. All right, now in terms of the types of SQL join statements, you will come across one of the six. All right, so you will either see an inner join, a left join, right join, full join, cross join, which is also called a Cartesian join, as well as a self join. So for this particular video, we're going to go through each of these joins, writing the SQL statements for them. All right. So this is the activity that we must complete by the end of this video. So we're going to create a database called DB store. We're going to create the tables given. We're going to insert the data that is shown in the tables, and I'll show the tables shortly. And you are going to carry out the join operations stated. So my advice is that if you are following along with the video, if you are using the video as a guide, I would say write down the questions that I'm going to show you shortly. All right, you probably can just write or draw off the tables as well. So just jot down the tables as well. All right, or you can pause the video and take down the tables, and then you can carry out your SQL commands, or you can write your SQL commands. All right, so these are the tables. So we have three tables working with. The first one is called salesman. All right, so you're going to create the salesman table. You're going to create another table called customer. And then your third table will be called orders. Now remember, these tables will be created in our DB store database. So we're going to create a database called DB underscore store first. And then we're going to create the salesman table, the customer table, and the orders table. All right, now after we create our three tables, well, create a database along with the three tables, these are the requirements. So we're going to write the appropriate SQL commands to carry out an inner join on the salesman table and the customer table. All right, your result should display the customer ID, grade, and the name of the salesman. So that's the first requirement. The second requirement is to write the appropriate SQL commands to carry out a right join on the orders table and the customer table, right, using the salesman ID. Your result should display the order number, customer ID, and the purchase amount. The third requirement is to write the appropriate SQL commands to carry out a left join, so left join this time, on the orders table and the salesman table. Your result should display the order number, customer name, and the order date. Our fourth requirement, we're going to write the appropriate SQL commands to carry out a full join on the orders table and the salesman table. Your result should display the order number, customer ID, as well as the city. And then additional requirements, we'll be doing a cross join, all right, or otherwise known as a Cartesian join. So we're going to write the appropriate SQL commands to carry out a cross join on the customer and the salesman tables. Your result should display the customer ID, grade, as well as the salesman name. All right. Another additional requirement is to carry out a self join. All right. So we're going to write the appropriate SQL commands to carry out a self join on the orders table. Your result should display the order number, the purchase amount, where the purchase amount is greater than or equal to 900. All right. So hopefully by the time we are finished writing these SQL commands, it will become a little bit clearer in terms of you understanding the different joins that we can carry out. All right, so let's go now to the live demonstration where I'll be using, as I said, SQL Server within SQL Server Management Studio to write the actual SQL commands. All right, so as it relates to creating the database and the tables, I went ahead and did that. All right. So again, if you're going to be doing SQL join commands, I expect that you already know how to create a database, create a table, and insert data. All right. But I'll just scroll down on my screen, and what you can do is, let's say you don't remember how to create a database, you can just pause the video, create your database, create your tables, and insert your data. All right, so line 1, that's us creating the database. On lines 3 to 8, that's us creating the salesman table. 10 to 16, lines 10 to 16, we're creating the customer table. 18 to 24, we're creating the orders table. Very important is the foreign key references. All right. So when you are doing joins, your foreign key is very, very important. All right. And then I proceed to insert the data given in each table. All right. For the customer table, I added an extra customer. All right. Because if we look at the orders table, there's also a customer ID 3001. So I added that one. So what you can do is add a customer with ID number 3001 as well as a salesman ID of 5005, and then you can just add whatever other information you want to add for customer name, city, and grade. All right. Then the insert for the orders table, and what is left now is for us to do our join commands. All right, I'm just comment this out. All right. So the first requirement was for us to write the appropriate SQL commands to carry out an inner join on the salesman table and the customer table. All right, and it says that your result should display the customer ID, grade, and the name of the salesman. All right, so let me just show you or give you a reminder of what the question is or what the first requirement is. All right, so this is the first requirement, and we are required to do an inner join. All right, and we're doing an inner join on the salesman and the customer table. All right, so with that, let us now go ahead and create the first join, which is an inner join. All right, so we're going to say select. All right, so the table, that will be the first table, is the salesman table. So we're going to say select salesman, and from the salesman table we want the name of the salesman, so we're going to say dot s name, which is what I had called the salesman name. So if I should go back to where we insert the data in the salesman table, salesman ID, and then s name is being used to store the salesman name. All right, so we want the salesman name. We then want from the customer table, we want the customer ID and the grade. So let's format this a little bit better. Let me just put the customer ID first, give it a little better look in terms of ID first, and then everything else will come after. So customer ID, salesman name, and then the grade from the customer table. All right, so select customer ID, salesman name, and customer grade. All right, so we're going to say from. All right, now the inner join, we'll place what we call the left table first, and then after the inner join keywords, we'll put what we call the right table. So table 1 will be the salesman table. Table 2 will be the customer table, which means that table 1, which is the salesman table, is our left table. All right, and customer will be our right table. But for the inner join, that is not necessarily important. All right, so we're going to say from salesman. We'll try this in all caps. Inner join. Now me writing it in all caps really doesn't make a difference. All right, all all uppercase, all lowercase, it don't make a difference. All right, customer. So we're doing select customer ID, salesman name, and the grade from salesman, inner join customer. All right, so we're going to use the on condition now. So this is being done on the matching column, which is actually the salesman ID, because again, if we should go back to the creation of the customer table, we realize that the salesman ID in the customer table is a foreign key. All right. So the foreign key right here is maintaining our referential integrity, which means that the two tables are linked based on that foreign key. All right, so it is being done on salesman dot salesman ID is equal to the same thing from the customer table dot salesman ID. All right, and that is our inner join. So I'm just going to go up here and click execute and look at our results down here. So it told us that the query executed successfully. All right, and this is our information. So this is our inner join. So you realize it gave us the customer ID, salesman name, and the grade. All right, so the inner join was completed. All right, so again, this is the command for your inner join. All right, so just to put some context to it, all right, the inner join returns records that have matching values in both tables. All right, so once there are matching values in both tables, then the inner join will be successful. Now, what is being matched is the salesman ID. All right, so salesman ID from both tables are being matched. All right, so even though we did not display the salesman ID, it is still being used to ensure that only matching records are displayed. So records with matching salesman ID, that will be displayed. All right, so again, your inner join returns records that have matching values in both tables. All right. All right, so our second requirement is to carry out a right join. All right, so we are supposed to carry out a right join on the orders table and the customer table. And again, it is asking us to use the salesman ID, all right, to carry out this right join. All right, so the syntax for the right join is pretty much similar to that of the inner join. All right, so I'll show you that shortly. Let me just comment this out. All right. All right, so to proceed with the right join, we're going to say select. All right, and what we want to select now is we want to display the order number from the orders table, the customer ID from the customer table, and we also want the purchase amount, all right, from the orders table. All right, so let me just clarify something. If you look in the orders table, you will see the order number, purchase amount, and customer ID. All right. So persons might say we would need a join for that. But again, this is just being done to demonstrate how the right join works. All right. All right. So let's proceed with our SQL command. So we're going to say select, and we want from the orders table the order number, and then we want from the customer table the customer ID, and again from the orders table we want the purchase amount. All right, So we are selecting this from. Alright, so again, the table that is listed first is seen as the left table, and the table that is listed second is seen as the right table. Alright, so we are doing orders as the left table. Alright, and we're going to say right join, and we're going to do a right join on the customer table. Alright, so we want to say on. Again, this is where the matching record comes into play. And based on the requirement, they say that we should use the salesman ID as this matching column. Right? Not matching record, but matching column. Right? Or matching field for persons who rather use field over columns. Or some persons might prefer to say attributes or attribute. Alright? So matching field, matching column, matching attribute. So in this instance, it is still the salesman ID. So I'm going to say on order that salesman ID is equal to customer dot salesman ID. Alright, so if we should execute, let me just display this. Alright, so this right here is our right join. Alright, now what is being done is you realize that there are some null values. Alright, so that is possible with a right join, left join, as well as a full join. Right, there are cases where null values will be displayed. So if there's nothing from one table that matches that particular value, then we'll definitely get null. Alright, so again, that's the syntax. Or right, so this is how we'd write our right join. Key things to remember: we start with select, we use the keywords right join, and we say on. All right, so that's the basics of that. Let me just comment that out. All right, so let's see what the next requirement is. All right, so next they ask us to write the appropriate SQL commands to carry out a left join on the orders table and the salesman table. Right, your result should display the order number, customer name, and the order date. Alright, so we need to do a left join. Again, you can imagine it's pretty much similar to your right join. Alright, so you can sort of see a trend by now that doing the join or writing the join commands aren't necessarily complicated. Alright, the thing to do though is to understand how to use these, when to use them. Alright, that's a discussion that we can have in the future as well, in terms of when it's best to use them. But trust me, when it's time to use them, you will know. And when you don't need to use them, you will definitely know as well. Alright, so let's write the SQL for our left join. So it's select, and we're using orders and salesman table, and we want order number. So we're going to say orders dot order number And we also want the customer name. All right, so let's make a correction to the third requirement. All right, the question should read, write the appropriate SQL commands to carry out a left join on the orders table and the customer table. All right, and your result should display the order number, customer name, and the order date. All right, so because we're asking for the customer name, and the only place the customer name exists is in the customer table, the left join should actually be done on the orders table and the customer table. All right, so um, I made that quick correction right there to our requirements. All right, so what we want to select is the order number from the orders table, and we want to select the customer name from the customer table, and then we want to select the order date from the orders table. All right, so we continue by saying from orders, and remember again, this is a left join, so we're going to say left join customer. And again, what is common between the customer table and the orders table, we can use the salesman, all right? Because if you look at the salesman table, sorry, if you look at the orders table, the salesman ID is there. And if you look at the customer table, the salesman ID is there as well, all right? And let's just look at this in the command used to create the customer table. All right, so when creating the customer table, you see we have the salesman ID. When creating the orders table, salesman ID is there as well. But ideally, what we can do as well is instead of using the salesman ID as the foreign key to reference or as the matching column, we can go ahead and use the customer ID. All right, so customer ID would make more sense in this case because you see where the customer ID is a foreign key in the orders table. So let's use the customer ID instead, all right? Because the customer ID would make more sense here. So we're going to say on orders dot customer ID equal to customer dot customer ID. Right? Again, I really hope you understand why it makes more sense to use the customer ID as our matching column. Because as I said, if we look at the creation of the orders table, we see that customer ID is a foreign key inside our orders table. All right. Let's run this and see if it works. All right, let's see what is displayed. All right, so our left join was carried out. All right, so it gave us the order number, the customer name, and the order date. So left join was carried out. What will happen though if we use salesman ID? Let's just use salesman ID quickly and see if it would have made a difference. All right, so let's see if it makes a difference. All right, so nothing different. All right. Well, in terms of the number of rows displayed this time is different because if you realize we now have repeating customer name. All right, so that would be different. But again, as I said, the best thing to use would be the customer ID because the customer ID is a foreign key in the orders table. All right, so you realize all we need for the left join is just use the left join keyword. And again, the table that is written first, that's the left table, and the table written second, that's the right table. All right. All right. So for our sorry, for our fourth requirement now, we are going to write the appropriate SQL commands to carry out a full join on the orders table and the salesman table. And your result should display the order number, customer ID, and city. All right. Now I'll show you once I switch back to the SQL Server Management Studio screen. I'll show you where the salesman ID is a foreign key in the orders table, which means that salesman ID is the best matching column to use to join both tables. All right. All right. So if we look at the creation of the orders table, you realize that the salesman ID is a foreign key in the orders table. Again, the syntax for the full join is pretty much similar. So we're going to say select, and what we want to display now is the orders number or the order number. So orders dot order number. We also want to display the customer ID, and we can get the customer ID from the orders table as well. All right. So we're going to say orders dot customer ID, and we want the city from the salesman table. So we're going to say salesman dot city from, again using orders first, orders full join. All right, now with SQL Server, we can say full outer join. All right, so that can work as well. All right, so we're going to say from orders, full outer join, salesman, and we want to do this on orders dot salesman ID equals salesman dot salesman ID. If we execute, this will be our result. All right. Now, the thing with the full join, similarly to your left join and your right join, If there are no matching data sets or no matching records from one table with the next, then null will be produced. All right, so this null can be produced in this instance. All right, now I could simply remove the outer, run this, and the same result will be presented to us. So just to show that it does work, let me just do the join. By the way, the join is similar to an inner join. So by just typing join only, it's the same thing as saying inner join. All right, so let me just type back full, execute, and you realize it runs our full join. All right. With the additional requirements now, as we come closer to the end of this demonstration, we are going to do a cross join. So we are to write the appropriate SQL commands to carry out a cross join on the customer and the salesman tables. Your result should display the customer ID, grade, and salesman name. All right, so we're going to do a quick cross join. All right, so let me just comment this out. Now remember, the cross join in theory is also referred to as a Cartesian join. And if you remember anything about or know anything about Cartesian product, then that would give you an idea in terms of how the cross join work. Right? So it basically matches every single row from one table with every single row from the next table. So it's like you're doing a Cartesian product calculation. Alright, so if you don't know what the Cartesian product is, then you can just do a quick Google search of that for me. Alright, so as the requirement stated, we are to do a cross join on the customer and the salesman table. What we want is customer ID, grade, and salesman name. Alright, so let's go. So we're going to say select, and what we want is the customer ID, the grade, and the salesman name. So I'm just going to say customer dot customer ID, and we want the grade, so we're going to say customer dot grade, and then from the salesman table we want the salesman name, so salesman dot s name. All right, and we want to say from the customer table. Alright, now to do the cross join, we type cross join. Alright, and we're doing the cross join on the salesman table. Alright, and that is it. No on clause is needed, because as I said, what it will do is it will take every record from one table and do a Cartesian product with the second table. Right, so it's going to do a Cartesian product with the first table, well, with the records from the first table and the records from the second table. So let's just execute this and see what it looks like. Alright, so if you should look at our results, you realize that it takes the customer ID, because we have customer ID from 3001 to 3009. Alright, so the salesman name is from the salesman table. So it goes with the first salesman name and matches that to the records from the first table, which is the customer table. Alright, then it repeats that process of taking the customer ID from 3001 all the way to 3009 and then matches the salesman name the same salesman name with all those records. So it's doing a Cartesian product. Again, importantly, just look up Cartesian product for me if you are not familiar with what that is. All right. All right. So the final thing that is required of us is to do a self join, and the self join will be done on the orders table. All right. So our result should display the order number and the purchase amount where the purchase amount is greater than or equal to 900. Alright, so you can look back on the orders table just to get an idea of what it contains, alright, in terms of the different columns. Alright, so the self-join is a unique one in a sense where it joins a table to itself, right, if that makes sense. Now, I have never used the self-join for any practical purpose. But who to tell, you might be creating an application and you see where you can go ahead and use it, then no problem. All right. Well, let me just show you what the SQL for the self join would look like. So I'd say select, and I'm going to give each table, I guess we can call this an alias or a nickname if we want to call it that. So I'm going to say a dot orders. So that's the first instance of the orders table because remember we're joining it to itself. All right. Sorry. Let me not say. Let me just rewrite that. All right. I need to put the columns first. All right. So just as a refresher, the columns that we need are the order number column and the purchase amount column. All right. So definitely after select should come the column names that we want. All right. So I bad on that one. So we're going to say select A represents the first instance of the order table. So we're going to select A dot order number, and let's just take the purchase amount from the second instance of the orders table. So I'm going to just say B dot purchase amount. All right. We're going to say from now A dot orders. That's the first instance, and then all right. No, I should say orders A. Right, that's how we want to write it. So we're now associating A with the first instance of the orders table, and then I'm going to say orders B. All right. And if you remember, it says where purchase amount, uppercase, lowercase don't really matter. All right. Where purchase amount, all right, where purchase amount is greater than or equal to 900. So this should be interesting. All right, so let's see. Oh, let me associate this with the purchase amount from B. All right. All right. So this should be interesting in terms of a result. Let's execute and see. Moment of truth. All right, and this is what it gave us. So again, it does a self join, and all it gave us was all purchase amount that was equal to or greater than 900. But you realize now because it's a self join, it works similarly to the Cartesian product. All right, you realize the word join wasn't used any at all in this particular one. Okay. All right, so as a quick recap, We looked at the SQL commands to create your inner join, left join, right join, full join, cross join, and self join. Now, for the inner join, it returns records that have matching values in both tables. All right, that is very important to note. For the left join, it returns all records from the left table and the matched records from the right table. All right, and with the left join, there are instances where you can get null values. Okay, now with the right join return all records from the right table and the matched records from the left table. Now the right join as well can produce null values. And for the full join returns all records when there is a match in either the left or right table, and this as well can result in us getting some null values. Alright, for the cross join, also known as the Cartesian join, there is, well, this is the case where there is a join for each row of one table to every row of another table. Alright, so the Cartesian join or cross join usually is usually used when the matching column or the where condition is not specified. So if there is no matching column and or there is no where condition, then naturally it will result in a Cartesian join, or what we'll use is the Cartesian join. So if no where or no matching column is specified, then you'll go ahead and use your Cartesian join. And finally, for the self join, as the name suggests, it does a join on itself. All right. So we would make one instance of a particular table and then make another instance of the same table, and then we'll proceed by doing the join. All right. So feel free to just rewatch the video, rewind to certain parts where you can see the SQL for the inner join, left join, right join, full join, cross join, and self join. Now, are those the only way to structure your SQL commands for these? No, right? Not necessarily, but they are sort of straightforward, and it does teach you the concept of how to write the SQL commands for each of these joins. All right. So basically, as I said, write down the questions, create your database, create your tables, and then try to write the joins. What you can do as well is think of other examples that you can use, to test the different joins. All right. You can also, you know, look up how you can write the joins. So look up alternative ways of writing the join commands. All right. So basically, yeah, do the activity as best as you can. Maybe pause the video at points, do it, and then see if yours look the same and if you get the same results. All right.